this is dealing specifically with problem number 5 on the Unit 3, Part 1 practice test, but it's relevant to inverse functions in general. In order for the extreme value theorem to apply, a function has to be continuous over a closed interval. Now notice it doesn't say differentiable, because you can have a function that is not necessarily differentiable at all points, but is continuous, and if it is over a closed interval, it will still have a absolute maximum and an absolute minimum. For example, you could have a function that looks like this, which is not differentiable the closed interval a to b, but is definitely continuous over the closed interval and has a absolute minimum and an absolute maximum. Let's take a quick walk through the incorrect choices. The first one is A, tangent x. Well, we know what the graph of tangent looks like. Here's the xy axis, and at every odd integer multiple of pi over 2, we have a vertical asymptote. So it is not continuous over the interval 0 to 4, 3 pi over 2. That might be less than 3 pi. I'm not sure where 4 would be, but it's certainly pi over 2 is within that interval, so it is not continuous. So A is gone. Looking at C, I can factor that expression, that rational function there, as I've just illustrated, and since I have x minus 4 on the top and on the bottom, that would create a hole at x equals 4, and since it has to be a continuous closed interval, that means that it would not exist at 4, so again, doesn't satisfy the requirement of the extreme value theorem. So that one's gone. Let's take a look at the last one, 1 over e to the x minus 1. Well, if x equals 0, then e to the x equals 1, and I would have 0 as my denominator. And we know we can't have that, so it would not be continuous at 0. So that one's out. It just leaves us with B, but let's kind of explain why this is the case. So we know that the tangent function, the domain of the tangent function, is negative infinity to infinity, except odd integers multiples of pi over 2. And we know that the range of the tangent function is negative infinity to infinity. Here's a little snip of the tangent function, and as you can see, at well, there's these vertical asymptotes that are happening. For example, like right about here, and somewhere right about here. So clearly not continuous. So let's just take a little pause here and discuss, well, what is an inverse function? So here I have a function, a very simple linear function, y equals 3x plus 2. So all an inverse means is that I'm going to switch the x's and the y's. I'm just flipping the x's and the y's. So the inverse of this function would look like this. X equals 3y plus 2. And that is called the implicit inverse. Now, we usually like to solve for y. So I would want to really make this, I would change this to 3y equals x minus 2. And then I would divide both sides by 3, and I would get y equals x minus 2 divided by 3. That is the explicit inverse. And you can't always get an explicit inverse, but sometimes you can, and it's always good to try. And we write that f minus 1 x. The minus 1 is telling you that it is an inverse function, so the x minus 2 over 3. Now, we know that domain are the x values, and range are the y values. So when we do an inverse function, we actually switch the domain and the range because the x's are becoming the y's and the y's are becoming the x's. So let's go back to our problem here. This is the domain and range of the tangent function. Well, we want the inverse tangent function. So the domain of the inverse tangent function is going to be negative infinity to infinity, and the range of the inverse tangent function is going to be negative infinity to infinity, except. So to solve that, we're going to come back to this in just a second here, and we're going to accept dot, dot, dot. The domain of the inverse tangent function is negative infinity to infinity, and that means it's continuous. It means it has every value between negative infinity and infinity. So it certainly has every value over the interval 0 to 4, and that's why B is our answer. But let's just take a minute here and look at the graphs. Because if I look at x equals tan y, that is the implicit inverse of the tangent function, well, you can see it's not even a function at all because I don't pass the vertical line test. But just like if you remember inverses, we always limit it to negative pi over 2 over pi over 2. The actual graph of the inverse tangent function only has this one particular layer right here. And you would find that we have a horizontal asymptote at negative pi over 2 and another one at positive pi over 2. So I hope that answers this question.